In this video, we're going to look at adjusting the paneling parameters of an airfoil when you load it into Xfoil. This is useful because it will allow you to balance the speed of the computation time versus the quality of results. Brought to you by the Science of Flight. Let's get to it. In this video, we're going to look at adjusting the airfoil paneling parameters. The goal, of course, is to get you to the point that after you load an airfoil into Xfoil for analysis, you're able to go in and adjust the paneling parameters to suit your needs. The purpose of this, of course, is to be able to balance the quality of the results you get with the computational time required to run Xfoil. This can also be helpful when you are running an analysis on an airfoil and it does not want to converge. The first step is going to be to load the airfoil that you're wanting to perform an analysis on and change the paneling parameters on. For this tutorial, we're going to use the NACA 24012 airfoil. It's a 5-digit airfoil. We're just going to go ahead and use Xfoil's built-in NACA command to load that. And when you use the built-in NACA command, you'll see that it's going to generate some information on the screen. I have it right here on the slide there on the right in the green. If you look towards the bottom, there's going to be that section right there that says paneling parameters used. The idea behind this tutorial is to show you what those parameters are and how to change them. There are two methods that Xfoil uses to determine the paneling of an airfoil. The first method that Xfoil uses is shown here on the left. This method uses the paneling parameter values that are stored in Xfoil. Xfoil does have some defaults stored so that if you haven't specified any, it does have default values. And so what it does is it uses these paneling parameter values to essentially spread out the number of panels around the airfoil shape. However, there is something to keep in mind, is that Xfoil has a second method that it could use to determine the paneling of the airfoil. The way this method works is that it will use the airfoil coordinate points from the buffer airfoil memory to determine where to place the panels. If you remember from the previous slide, when we loaded this NACA airfoil, it told us that it used 331 coordinate points to make the airfoil. Now, if you use this method here on the right, you'll notice that it is going to create 331 panels. This is because this method will use each coordinate point as the endpoints of a panel. So it'll just connect the dots from the airfoil coordinate points. Using this secondary method, there is no adjustment of the panels. It's what you have is what you get. After you load an airfoil into Xfoil, it's recommended that you run the pane command to smooth the shape of the airfoil. This, of course, is if you're wanting to use the pane method that we talked about on the previous slide. If you're wanting to use the airfoil coordinate points instead of the paneling parameters that are saved in memory, then at the command prompt you type in PCOP. Now, the rest of this tutorial is going to use the assumption that we are using the paneling parameter method, basically because the other method, the coordinate point method, you're not able to adjust. So this one's going to just continue with the pane method and show you how to adjust those values. Now, if you're wanting to look at what the paneling parameters are, and you can look at them without actually choosing to use the method, using the PPAR submenu, and this is actually the submenu that we're going to drop into as well to adjust or change the paneling parameters. When you enter the PPAR submenu, you're going to see the text here displayed on the screen. It's going to show you the different paneling parameters that are available to you, along with giving you a prompt allowing you to change the parameters if you're wanting to. This is set up very similar to the other menus in Xfoil, where the first column is the command. So this would be what you type at the command prompt. The second column would be the parameter column. I stands for integer, R stands for real. Multiple letters means it's going to ask for multiple values. So if there's two R's, it's going to require two real numbers from you. The third column is going to be the description of what the parameter is. And the fourth column is going to be the current value of the parameter. So for instance, if I wanted to look at the second paneling parameter, the panel bunching parameter, if I look at the first column, that P is what I need to type at the change what command prompt. And in the second column, I see one R, so it's going to require one real number. And the current value in the last column is 1. So if I wanted to change that to 1.5, at the change what command prompt, I would type in P, a space, and then 1.5. And if I forget to put the 1.5, Xfoil will prompt me for that value. If you are satisfied with what the values have been changed to, go ahead and hit enter and it'll take you up a level. The first parameter that is used is the number of panels that is used when modeling the airfoil shape. The default number of panels is 160, and this is usually a pretty good number to have. So I've got two examples here. For the top one there, you'll see that I changed the number of panels to 50. On the bottom one, you'll see that I changed the number of panels to 300. So you can kind of see the difference between these two, the difference between 50 panels and 300 panels. 50 looks a little bit too sparse for this airfoil, so I would definitely try and kick it up a little bit more than that. But 300, as you can see, it's got a really good representation of the airfoil, so I don't know if I'd really go up above 300 for this. In fact, you'd probably be good at 200. The next paneling parameter is the panel bunching parameter. The panel bunching parameter is used to distribute the number of panels unevenly on the airfoil. The idea being you're wanting to use more panels where the airfoil geometry is changing the most, parts that have the highest curvature. So this pretty much falls to the leading edge and the trailing edge. So as you increase the panel bunching parameter, you are essentially telling Xfoil to take more of your panels that you have and place them at the leading edge or the trailing edge, and to not place as many airfoils on the more flatter parts of the airfoil. This is one of those tricks where you can get some higher quality results without the necessary computation time, because you're placing the panels at the important areas of the airfoil and you're letting it be more sparse on the not as important areas. I went ahead and I chose two different panel bunching parameters to try and show what this parameter does. So if I change this bunching parameter to a 0, that's telling Xfoil I do not want you to bunch the parameters around the areas of highest curvature. So as you can see by the top airfoil, pretty uniform in terms of the size of the panels and the distribution across the airfoil shape. However, if I went crazy, like on the bottom one here, and I told it that I wanted a panel bunching parameter of 10, you'll see here that the 160 panels are mostly jammed towards the leading edge and the trailing edge of the airfoil, because these are the areas with the highest change of geometry, right? The highest curvature. Now it's recommended to keep this number between 0 and 1, though you're not forced to. For instance, as you can see on the bottom, Xfoil let me do something like a bunching parameter of 10. This is one of those that requires your judgment as the engineer on a decent value to use. The next paneling parameter is the trailing edge to leading edge panel density ratio. As the name suggests, this is a ratio. So we're comparing the trailing edge panel density to the leading edge panel density. So I have a couple of examples here to show you what that ratio is. Now, let's start with a ratio of 1. If I have a ratio of 1, that means the numerator and the denominator are the same number. So if we represent it with, let's say, a 1, so that means that the trailing edge panel density is 1 and the leading edge panel density is also 1. It's the same value. So this is the ratio between the two values. So since they're the same, the ratio would be 1. So that's the first one you see up there. And so what you can see is that the paneling is the same between the leading edge and the trailing edge. They're bunched the same. There's not one or the other that has a lot more panels than the other. So it keeps it even. So what would happen if I made this ratio 0? That's essentially saying that the trailing edge panel density is 0, while the leading edge panel density is 1. So what this is saying is that we want to put 0 of our extra panels at the trailing edge, and we're wanting to put all of them on the leading edge. As you can see there by that middle airfoil, the trailing edge looks normal. It doesn't look like it's bunched at all. If you look at the leading edge, you'll see that all the extra panels have gone there. Now, this bottom airfoil that I have here is showing something that's not quite the opposite, but it's heading in the opposite direction, right? And that is a panel density ratio of 10. So what this would be saying is that the trailing edge panel density is 10, while the leading edge panel density ratio is 1, right? So we're saying we want to stack all of our extra panels at the trailing edge instead of the leading edge. So as you can see by the airfoil there, you get some really good bunching at the trailing edge, but you don't see any real bunching at the leading edge. A quick note, this parameter is used in conjunction with the panel bunching parameter. So if you have panel bunching set to 0, it doesn't matter what you have for this parameter because it doesn't have any extra airfoils to throw either at the leading edge or the trailing edge. So it just distributes it evenly. The next 3 paneling parameters we're going to cover together because they're interconnected. The first is the refined area to leading edge panel density ratio. So this is similar to the previous slide where it was the trailing edge to leading edge panel density ratio. However, for this one, it's going to be the refined area. So what is this refined area? Basically, Xfoil is giving us one other area on the upper surface as well as one extra area on the lower surface that we can use the extra panels that we get from doing the panel bunching. So we're able to choose a part of the upper surface and a part of the lower surface that we want to bunch up and have more panels in. And that's what the bottom 2 commands are doing. We're telling it where we want the refined area, right? This area of extra panels, where we want it to start and where we want it to end. So just for this one, I chose that the upper surface was going to have a refined area from 20 to 40% of the chord, and the lower surface was going to have a refined area from 40 to 60% of the chord. You can see that Xfoil went ahead and colored those areas purple. As we talked about on the previous slide, this is a ratio of panel densities. The ratio, of course, being between the refined area and the leading edge. We'll go ahead and cover the same 3 scenarios we used in the last slide. So if we put a panel density ratio of 1, this means that the refined area and the leading edge are the same value. So the panel density that you see at the leading edge is going to be the same as the panel density over the refined area. Now, depending on how large this area is, that might mean that you're taking a lot of panels and putting them at the leading edge and over this area. So that's why you're starting to see towards the trailing edge of this upper surface, it's starting to get pretty sparse. Now for the middle airfoil, if we change the panel density ratio to 0, this means that the refined area is getting 0 of the extra panels, and the leading edge is getting 1 or 100% or all of the extra panels. So if you look closely at that airfoil, you'll see that the leading edge has bunching. However, our refined areas do not. They look normal like the rest of the airfoil. I don't see any bunching on them. Now, if we try to choose a value going the other way, not quite the opposite of a 0 ratio, but something kind of headed in the opposite direction. If we chose a ratio of 10, you'll see that that is essentially saying that I want the refined area to get 10 times as many extra panels as the leading edge does. So if you look at this airfoil, you'll see that the refined area has a lot of panel bunching and the leading edge does not. In fact, it's taking up so much that the rest of the airfoil is looking pretty sparse, like they need more panels. Now you might be asking, why do we need a refined area? A refined area is usually a good thing to use around a transition area where you might be transitioning from laminar to turbulent. That would be a really good spot to try and put this refined area. You might have a bubble on the upper surface of your airfoil. That would be another good place to put this refined area. The last two commands in this paneling parameter menu are not actual paneling parameters. They're just commands to manipulate the window where you're viewing the panels. So you have zoom and unzoom, and those do just what you think they're going to do. They're going to allow you to zoom in on a specific area of the airfoil, or if you use unzoom, it's going to zoom you back out to the default view. You're telling Xfoil that you want to see this rectangular area of the airfoil, and it'll zoom up onto that rectangle. And that's just accomplished by typing in the zoom command and then clicking two opposite corners of the rectangle that you want to zoom in on. So on this one, I click the upper right corner and lower left corner of the airfoil that I wanted to zoom in on. As you can see on the window to the left, it zoomed in on that box. I could have easily have chosen the upper left and bottom right corners as well. They just have to be opposite corners because you're using those 2 points to draw a rectangle around the area you want to zoom in on. So that's the end of the paneling parameters in the sub menu. When you're done changing parameters, just hit enter a couple times. If you changed a parameter and you're wondering why it doesn't show that in the secondary window, hit enter again and it should appear. This usually happens because Xfoil is trying to collect all of the parameters you want to change before updating the paneling parameters and the graphic. So it's just asking, all right, what's the next value you want to change? So when you hit enter, you're saying that's it, I don't want to change anything else. And then it will go ahead and update the paneling parameters and update the graphic. Something else to keep in mind is that if you're wanting to save changes that are made in the QDES menu, if you use the pane or the PCOP commands, it will actually overwrite some of your data. So just be careful. Another quick tip is that the maximum angle between adjacent panels that is shown in the secondary window with the airfoil that shows the paneling, this maximum panel angle is often used as a measure of how good the current paneling model is. So we're trying to get that value to be very low. We don't want a very sharp change in the angle between the panels because it's not going to give as good of results. So if you load an airfoil that has some terrible geometry, oftentimes Xfoil will prompt you and let you know, hey, there's a max panel angle of 40 degrees. It's recommended to use pane or whatever it says. So keep in mind that if you see an abnormally high max panel angle, it would be a very good idea to go to this paneling menu and adjust the paneling parameters, whether that's adjusting the bunching parameter, whether that's adjusting some of the density ratios, or just the number of panels. And hey, you know how to do that now. The last tip or recommendation I would give is that the default paneling parameters are usually good enough. There might be some cases where you might need to add some refined areas for bubbles or or transitions, or you might have issues converging. And so that might be an instance where you might look at changing the paneling parameters, but usually the default values are pretty good. So if you just run the pane command after you load an airfoil, you should be set most of the time. We're going to go ahead and end the video here. In this video, we talked about the different methods that Xfoil uses to panel around an airfoil shape, as well as how you can adjust the paneling parameters that Xfoil uses. If you haven't already, go ahead and like, comment, subscribe, and I will catch you in the next video.